Section 2.7, Video 4. Verifying logic arguments, common arguments, and fallacies. In this section, we'll cover the objective of identifying some common forms of fallacies. Let's begin with the definition of a fallacy. A fallacy is an argument with faulty reasoning that results in an invalid conclusion. A fallacy can seem like a strong argument. However, upon inspection, there is a hole or problem with the logic used that makes the conclusion false. As an example, from example 2 in section 2.7, in video 1, we were given the argument about if Caden is watching The Office, then he laughs. And we were given a second premise statement that Caden laughs. We discovered that the conclusion, therefore Caden is watching The Office, made the argument invalid. And there's our truth table that shows that when we had premise statements that were true, not all of the conclusion statements were true, making our argument invalid. Let's take a look at some common fallacy forms. Note that all of these forms you can use a truth table to prove that the argument ends up invalid. But anything that has these forms will be an invalid argument. The first common form is called fallacy of the converse. You're given a conditional, if P then Q, and the second premise statement you're given is statement Q. The conclusion of statement P does not make the argument valid. The reasoning for this is when you're given an original conditional, in this case, the given original conditional was if P then Q, or in symbolic notation, P arrow Q. Recall that we would have the converse as statement Q implies P. We'll also talk about the statement inverse as statement negation P implies negation Q, and the contrapositive as statement negation Q implies negation P. We found that the original conditional and the contrapositive will always have the same truth values. That's why when we investigated the common forms of valid arguments, the contrapositive reasoning was a valid argument form. We also found that the given conditional and the converse will not have the same truth values in every case. So that's the reasoning for why the fallacy of the converse will make this argument invalid. An example, if it is raining, then there are clouds. If we know that there are clouds, does that imply the conclusion that it is raining? And it doesn't. There are days that there are clouds when it's not raining. So just knowing that statement Q is true does not imply that statement P is the conclusion. The basis for that is that when the original conditional is if P then Q, the converse, if Q then P, will not always have the same truth value. It's a very similar reasoning for the fallacy of the inverse. Given an original conditional of if P then Q, the inverse of negation P implies negation Q does not always have the same truth value as the original conditional. When you're given a premise of if P then Q, knowing the negation P does not imply the conclusion negation Q. For example, if it is Friday, then Carl eats pizza. If we know as a second given statement, premise, that it is not Friday, that does not imply the conclusion that Carl does not eat pizza. As an example, Carl could eat pizza every day of the week. Just because it's not Friday doesn't imply that Carl's not eating pizza. The third common fallacy form, misuse of transitive reasoning. If you remember, transitive reasoning started with the conditional if P then Q, and then the second premise statement was if P then R, and the valid conclusion was if P then R, using Q as the transition. In this case, they're trying to use the converse by switching the order. And notice and recall that the direction of the implication, the direction of the if-then, in this case, the antecedent needs to be statement P and the conclusion should be statement R. And in the misuse, it is not that direction. For example, if it's Friday, then we go bowling. And if we go bowling, then we eat pizza. The appropriate conclusion would be starting with it is Friday and ending with eating pizza. This conclusion goes the other way around. If we eat pizza, then it is Friday. And remember that the original conditional and switching the order for the converse do not always have the same truth value. The second misuse of transitive reasoning uses that idea of the contrapositive. If the appropriate transitive reasoning would have the statement if P then R, an equivalent would be the contrapositive negation R implies negation P. So switching the order to be negation P implies negation R would not have the same truth value. And that again would be a misuse of transitive reasoning, using transitive reasoning incorrectly. The misuse of disjunctive reasoning, disjunction is an or statement. So we are given P or Q, and again the given statement is true. But we also know that statement P is given, so statement P is true. Does that imply the conclusion that statement Q is false or negation Q is true? And it doesn't. Remember that with an or statement, you could have one statement true or both statement trues. We just need at least one of them to be true. An example, Ryan likes the Ford Raptor, or he likes the Nissan GTR. The second given statement tells us that Ryan likes the Ford Raptor. That doesn't necessarily imply the conclusion, therefore Ryan does not like the GTR. It is possible for Ryan to like both of those vehicles. Another misuse of transitive reasoning would be given statement P or Q, but also confirming statement Q is true. Using that same given conditional, if Ryan likes the Ford Raptor or the GTR, Ryan likes the Ford Raptor or the Nissan GTR. But we also know that Ryan likes the Nissan GTR. It doesn't necessarily tell us whether Ryan likes the Ford Raptor or not, because it is possible for him to like both vehicles. Let's take a look at example 6. If we're given an argument, let's convert it into symbolic notation and determine what form it takes. If it is Beckham's birthday, would be our statement P, then implies he went to his favorite restaurant, and that is statement Q. The second premise statement confirms that Beckham went to his favorite restaurant. That would be statement Q. And we're checking on the conclusion, it is Beckham's birthday, and determining if that conclusion makes the argument valid or invalid. In this case, it fits the form fallacy of the converse. Remember that the converse switches the order of the original conditional. If statement P, then statement Q. So if you're given statement Q, does that imply statement P? And we're given statement Q, and we're trying to determine if that will make, if our conclusion statement P will make the argument valid or invalid. So this fits the form fallacy of the converse. Example 7. Again, let's convert our argument into symbolic notation. Marisol went bike riding or swimming. We could make that two statements. Marisol went bike riding, which is statement P, or disjunction, Marisol went swimming, statement Q. The second premise statement, the second given information, is that Marisol went bike riding. And if Marisol went bike riding, we're confirming statement P is true. Therefore, can we make the conclusion Marisol did not go swimming, which would be a negation Q. This is an example of the misuse of disjunctive reasoning. With a disjunction, an or statement, at least one needs to be true. If we know that statement P is true, it does not necessarily tell us any information about whether statement Q is true or whether statement Q is false, because they could both be true. So this is an example of the misuse of disjunctive reasoning. And that ends example 7.